Okay, and this one here, if you recall, they want you to identify the domain and the range. Now, I'm going to show you the graphs for this one because if you recall, the parent function is y equals square root of x, right? We know that one to be the one that starts at the origin and goes like this, correct? So this is some variation of that. It's transformed. So let's go to the graphs so that we can see what's going on. And here I graphed the parent function in blue, and then I graphed the transform function, the square root of x minus 3 in red. And if you notice, it just went down 3 units. Okay, in other words, this is our k. Our k goes up or it goes down. Same thing as the quadratics, right? Because it's outside of the square root of x. So since it's negative 3, it went down. Well, if we look, it really doesn't change the domain. The domain is the same from 0 all the way to positive infinity. Okay, so in that case, our domain stays the same. Our range, though, it used to be from 0 all the way to positive infinity, right? From 0 to positive infinity forever. But now, instead of starting at 0, it's starting at negative 3 and going up forever. If you notice, the negative 3 is right there, correct? So the domain stayed the same. The domain was x is greater than or equal to 0. The range changed. The range became y is greater than or equal to negative 3. Okay, so remember those two things. We're going to come back over here. We said the domain was x is greater than or equal to 0. We said the range was y is greater than or equal to negative 3, correct? Let me show you how to do that by hand over here. Okay? Here, we're supposed to have, when it transforms, we're supposed to have a square root of x minus h, just like the quadratic, and then plus k, right? So if we look at this, the x minus h is on the inside. Well, our h happens to be 0 here, so pretty much what you do is, you do whatever it is, you take everything in here, okay, and then you solve for x. So you would put this right here, the 0. If you had an h, it would have been x minus h, and then solve for x. You bring the h across and solve for x. But in this case, there's nothing there. So in other words, there's nothing to solve for. It's already solved. This is the answer. And sure enough, it was like that. On the range, all you do is you look at the k. In other words, the range is going to be y is either greater than or equal to k, or it's going to be y is less than or equal to k. And how do you determine that? You determine that by the a. If the a is positive, then the graph goes like this. If the a is negative, then the graph goes like this. Okay? So obviously, if it's going up, then it's greater than k. If it's going down, it's less than k. So in this case, my a here is a positive 1. So that means that my graph is going to be going up. Okay, so that means that the y is going to be greater than or equal to, and then you look at the k, whatever number that is, you put it right here. Okay, and that's the way you solve for domain and range.